Alright, so we'll be doing some code today. So we'll be working on the port B and port A registers. So we'll be doing some stuff with it. And you'll get accustomed to some stuff in the code for you to understand. So we working with port B. So we want 3 LEDs. So we want the LEDs to be on RB0, RB1, and then RB2. So I'll just bring it down. So that's where we want the 3 LEDs to be. Right, so we'll just remove this because it's not needed anymore. So that's the idea. So right now you should be thinking if it's an LED, that therefore the pin have to be an output. It has to be digital, and that is the things that should be coming to mind automatically, right? And then on RA7, no, sorry, RA, let me say RA1, we want to pass switch. And this switch just go and control the LEDs at the same time. So we're not trying to control them separately. Trying to control the RA1, sorry, the RA1. Once we switch the RA1, we're gonna be switching the 3 LEDs one time. So you're clear with that? So we're gonna assume that your board was set up already, hardware, because hardware and software does interlink. So we are assuming the hardware, say MPLAB, your power, and your oscillator was already connected, and what you check to make sure it's good, and we go ahead. So now we just go and jump into the code. So I'm just share my screen. Okay, right. So any code, 3 things. You already have your lists include your configs, and then you have your introductions. Okay, and we add main. So normally, as a rule of thumb, the first thing you will do when you're coding is your main program would just be a configs. So you're just configuring your pins. So your configs for your pins. So like setting your outputs, your inputs, and whatever you need. Just to configure the board. You're not doing anything in terms of code. You're literally just configuring the pick to do or the pins to do what you wanted to do. So the same registers that we went through yesterday, you had to use them to configure the pins. So the first thing I like to do is bank cell. The reason why we bank selling is because, as I showed you in the last video, the main registers, like the lots, the tris, all those are in bank 0. So because it's in bank 0, the default will be bank 0. So even if you don't bank cell and it goes to the default, you will still get through. But in some picks up all over the place, so you have to bank sell it. So just to be safe, we will just bank sell all the registers that we're going to use so they won't give you any warnings underneath. So let's work with the LEDs. So we say configs for LEDs. So the first thing you want to do is obviously set it to be an analog pin. So that would be answer, and since we're in the port B, it will be answer B. And remember to keep your columns, so because that will irritate you afterwards. So we bounce L, answer B. So what we want to do is 2 acronyms, bit clear flag and bit set flag. It literally does exactly what it does. It sets or clears a bit. So to set something to be a digital, any answer B, you have to clear the bits. But the cool thing about this, I think I kind of introduce you all to, you don't need to do it one by one. You could literally just do it in one or like you say 2 lines. Because if you want to do one by one, you have to do the same thing for every single pin in the port. So since all the LEDs are already in the same port, we could just set them to be whatever we wanted to do one time. And to do this, what we'll do, so you'll move a literal value into the working register. So the think of the working register to just kind of link 2 things together like a copy and paste. So you will use the working register to do a copy and paste. So you want to move a value to a register. You don't have a move L F, meaning you're moving a literal value straight to a file. or address or location. You don't have that. So what you had to do, you had to move it to the working register, and then from the working register, you move it to whatever file you want it to be in. So we want to move a binary value, so you had to use your comma, kind of like inverted commas or something like that. So 1, 2, 3, 4, 5, 6, 7, 8. So since we're moving this, we want the first, second, and the third, and just clean everything else. So since answer to set it to be a digital pin, it needed to be 0 or 1. So that we just make sure that is the correct thing. So to do that, you just go in your manual, and you should just search up answer relate X. Hey, alright, here. Now you just scroll down until you see them talking about the registers. There should be somewhere around. I think I passed it. Yeah, so here, just to make sure. So they said 1 analog input. So if you set the bit on the pin, it will be an analog. And then if you clear it, set it to be a 0, it will be a digital pin. So that is what this piece here tells you. So you can kind of check it in the manual. So now that we make sure, you can go back and do the correct thing. So since we already set everything to be zeros, we good. Now we had to move the working register to R5, and we're just moving it to answer B. So what we did here, we literally just clear the first 3 bits, which is each pins, and the rest we really care. So we set it to be whatever it is. Yeah, that's what we did. So the next thing we could do, after we set it to be a digital pin, we had to set the direction. So your bank cell, and what tells the direction is your trace register. So in your trace register, you're doing the same thing, but for trace, O or 0 is output, and 1 is input. So since it's an LED, it's had to be an output. So we'll move a literal value to the worker register, and we could just use the same 1, 2, 3, 4, 5, 6, 7, 8, and then you just move the worker register to the file, and trust me. So what we did there, we set the first 3 pins to be outputs. Instead of doing it one by one, you could just do it in one line. So we have digital, we have it to be outputs, to direction output. The ports, normally what a good thing to do is to clear your port. So one thing you can do or use to clear an entire register, instead of doing it one by one, is just a clearf function that clears the file. Now you just port B. If you wanted to, instead of here, you could have used the clearf, because it basically doing the same thing. It clears all the pins. If you could look and see all of them set to 0. So we could have just used clearf here, instead of using the mover W and the move WF. It will do the same thing basically, clear the file. So we clear the port, so any residuals stop that on the pins, it clears. Remember, you configure it, so you want a clean build. So we have digital, we have the direction, and we clear the pin. So we good. So it's an LED. So the second thing we want to configure is the switch. And remember, the switch was, let me go back to this. I believe it was our, show back up. See, yeah, R is 0. Yeah, R0. So basically first pin. So same idea. So what we do, we can copy this because it's basically the same idea, and paste it, and we just change the port data pin. So this is port A. So you just switch it to A, 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 and A. Just to make it work easier. So answer is still a digital input. So we still want them to be digital. So we could keep this line and this line obviously. And then the direction now is not an output, it's a switch. So the switch will be given values to the pick. So you want these to be inputs. So the first bit, you set it to be our 1, because 1 is for input in the trace register. And you move it, and then you circle it, just to make sure. And now, one more thing that we want to do is the lat A register. So remember the lat, the base, you just stores a value forever and ever. It just leaves it there. So since it's a switch, we don't want it to have any residual values in it. So you want to clear this file too. So we clear lat A. So we set digital is input, clear the port, and we clear the lat. So everything we did here is the end of the configs. So once it goes through this routine, your configs basically will be done. So now what you want to do is actually go into coding it. So the logic is you want to check the switch, and based on what the switch is, whether it's a 1 or a 0, you want to either put on the LEDs or take it off. That's basically the understanding of it. So the first thing you have to do is check the switch. So after your main configs, a nice thing to do is to go to switch check. So I go to another subroutine. And instead of doing everything in the main program, because it will just loop, configure, reconfigure, configure. So once you configure, you don't want to go back to that routine. Configure it already. So at the end of the configs, or your main configs, you can just write a go to, and it will go to another subroutine to do whatever you want it to do. So there's the name. So the names will go in the first column. So that'll be here. Tab it back to make sure. Right, so that's the furthest we could go. So that is your subroutine. So the first thing I want to do is check the switch. That is, you want to check it. Right? That is the most important thing. And the register that we could use to check instantaneous or current values on a pin is your port. So we want a bank cell. So remember it's on port A. So we want to check it. So we use something called bit test flag, skip if clear, or bit test flag, skip if set. It doesn't matter which one you use. It literally doesn't matter. It will do the exact same thing. You just have to write your subroutines based on what you wanted to do. So I just go and use bit test flag, skip if clear, and it does exactly what it says. It tests the bit. In this case, it tests in the switch pin, and it go and skip if it's clear. I mean, it literally just go and skip a line though. Literally, just skip a line. So what we testing port A, and you have to specify the pin. So this will be pin 1, because it's the first pin. If you want to put 0, I believe it will be the same thing but different picks. A 0 and 1. Remember, it's an 8-bit pick, so it's starting to count from 0. So RA0, RA1, RA2. Some picks you had to put 0, some of them you had to put 1. So you had to like play around with it to see, but most of the time RA0 will be 0, because that is what the name of it is. So you're checking that pin, and when it check, you want it to do skip, or it will just iterate down. So when they say skip, it will just skip this line, and it will go down to the other line. So you kind of have like 2 lines in which you want to do stuff. So remember, the switch could be either 0 or 1, depending on the voltage, because it's digital. So let me say, so it's bit test flag, skip if clear. So let me say it clear, which means that the switch in a 0 state, meaning it grounded. It could be on or off, depending on how you configure your switch. But let me say for now, it's grounded. So it's the pin C in a 0. So therefore, it will skip this line, and it will go down to here. So here now is where you want it to do. So what you will do, you will call, and you will call light LED. So let you say when it's 0, you want to light the LED. It could be any way you want it to be. It's based on your application. So in this case, for me, when the switch C in a 0, I go and skip, because I already instruction says, and we're going to call light LED. So we're going to call this subroutine to do exactly what it says, light the LED. So we go down, so you have to write the subroutine now. And you want to light the LED, so you have to use the lat register. So it'll be bang cell lat B. And since we want to set the 3 pins, we could use the same move LW, move WF stuff. So we kind of teeth it from on top, paste it. So we want to set or light the first 3 pins. So 1, 2, 3, 4, 5, 6, 7, 8. So this will let light or set 1 or center 1 to the pins, right? And it will light them. So we have to remove this and put lab B, sorry. So what it does, it selects the lat register, it moves 1 to the pins, and it sets it. So it basically will put on the LED, basically. So remember this move LW, move WF is like a copy and paste, right? So you're finished, but now I don't know where to go. So anytime you use a call, you must have a return. So you just return. So you return to whatever call it. That's how it does work. So that is your program counter and your stack. So when you say call, it stores that address on your stack. It goes to wherever you want it to go to. And at the end of that, you need to write a return. And when you engage this return, it will just pop the last address from the stack into the program counter, and it will just go back to where it was before. So those two things, very important. If you leave out this return, you will have an error in your code because it'll just keep on going down, 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 down. So you will never go back to this switch check. Remember, you want to continuously keep checking the switch. So it returns into the line right after the call. And then when that happens now, you want to go back to switch check. Remember, you want to continuously check the switch because that's how you will know if it's on or off or 1 or 0. Remember, it depends on how you configure your stuff. So we'll go back up to switch check and we'll just rinse and repeat the same process. But now we are the ready line when it's set. So when it's set, since I already say call light LED, I'll have to call, or I could say, yeah, call no light LED. So so when it calls no light LED, actually, if I call here, it will actually I can put the go to right after here. So what I will do, just to make my life easier, since the pins are already off, when it's set, it will skip. So now since it's clear, think about it. When it's clear, gonna skip, and I'm gonna have it on. So here now, I want to basically have it in such a way that it'll be off. So you have to remember that. So remember when it return, it actually gonna go to this line up here. So we had to be very careful in terms of what we do. So let me say we use our go to no light. So we wanted to go to. So remember go to doesn't come back. Yeah, so remember that go to doesn't come back. Call comes back. So we'll go to no light. So we just kind of copy and paste this routine because we're just doing the opposite. So what's the name of it? No light. Can't put any spaces. Yeah, so underscore. Copy this. Paste it here. And so now we want to take it off. So since we want to take it off, we could just, instead of doing all this, we could just use the clearF function. That's to make life easy. And here now, I can't use return because I can't return to go to. So I will just go to switch check. So I'll go back to checking the switch. If I had to use a call, it will return. So I'm gonna go through it. So after my configs, it will go to switch check. It goes to switch check. This is checking the switch to see whether it's a 1 or a 0. So if it's a 0, meaning it's clear, it can skip to light LED. It will go to light LED. It will set the first 3 pins to be a 1, so basically putting them on. And then it will go down here and put it on, you must send a return. I don't know why the return gone. and then return to here, this line, and then it will go back on top here, and it will just repeat the same process over and over. So when it comes back down here, assuming that the switch set, meaning saying at 1, it will just go down here, and it will go to no lights. So when it goes to this routine, it basically takes off the LED, and here now it goes back up here. If we had put a call in this line, it will have call no light. So what should happen? When it call no light now, it go back, here, go down here, and let me say I had a return instead of a go to, because remember call need a return. So when it does, it takes off the LED and it returns. But now when it returns into the light LED subroutine, and then it gonna light the LED. So basically it's gonna have it flickering if you can actually see it, depending on the oscillator. So that gonna be an error because now we are switch not controlling what you're doing. So you'll have a big error in what you're doing. So what you have to do now, this user go to, so you will jump out of this whole subroutine, and down here now instead of return, you just go to your switch check. And now we just repeat the same process over and over, infinite times. It's happening real quick. So you can really see it. So when you actually press the LED or however switch you have, when it sends a 1 or a 0, depending on how you configure your switch and your LED, whether it's a 1 or a 0, and what controls what it does when it sees a 1 or a 0 is your switch check routine. Your bit test flag or your bit set. So either way, it does what you want it to do. It depends on what you want it to do. If you want the LED to be on when the switch says 0, you could code it. If you want it to be off when it says 0, you could code it. Either way, you could code your stuff to do what you want it to do. So basically, this is an example of how you could control multiple LEDs in the same port with a switch. So we have our switch check routine because you will need something to check. So your switch check routine for sure. And then in your switch check routine, you have your bit test flag, skip if set or skip if clear, and your two functions. It depends on how you want it. Always sanity check your code. Like literally go through it to make sure that it will go to the correct thing. And we're just putting it on and just taking it off. Subroutine. And then at the end of this one, it goes back up to switch check. So let me just iterate through this. So remember, all this is program memory. Yeah? Program memory. We didn't use any data memory here, really. So when you start, so we can kind of iterate it like the program counter. So you will see this, and it goes down. And we'll go through all this. This is just your main configs for your board. You don't have to touch it. The only thing you might have to touch is basically your oscillator. XT is for low frequency and HS is for high frequency. That's kind of any manual. Other than that, until you do like a big project, you won't have to touch anything and you don't need to memorize this. So the program counter will go through all this. Well, that's how you treat it. They didn't really start the counters yet. So I'm not say program counter. So but it will go through all this is a main configs. Then now it will start organizing at this, which is a reset vector. So basically if you unplug back in, it will know what to do. So that is why they call it a reset vector. But I have to reset something. And then you have your 0x05. So you can start storing program memory at that address. Note I use org because it's trying to set the address. I could have put 20 here if I wanted to, once is more than 4. But I cannot put 02, 03, or 04. So those already use 04 is a interrupt vector. So let me say this 10. Hello. Then now it goes to main, because obviously you're not going to see this. It goes to main and it starts to store your memory at 0x10. So it goes through answer. So what it does, I will talk through what it does. This line, it sets the pins in port B to be a digital pin. Copy paste function, move out W, move W. That's basically what it does. Also, we could have just used a clearref because it will do the same thing. Then we set the direction to be an output because it's a LED, the pick given out a voltage. And then same copy paste function. Then it clears the port just for cleanness. So that's the LEDs. Now you go across to the switch. There's a program counter iterator. the program counter iterating through all these program memory addresses. So it goes to this one, it configures the switch, set it to be a digital, copy paste function or clearf, set the direction, so this one is our input, so you have to set the first pin to be a 1 because we're using array0. Array0 is the first one. Then, well, same copy paste function, then you just clear the port. And since it's an input, you want to clear the lat also, just for cleanness. Then that is the end of your config. So at the end of your configs, you want to jump to your subroutine. So remember, this is your main config routine. You don't want to do everything in your main routine. So you go to, note I say go to and a call, otherwise to come back. So I go to switch check. And what switch check does, it does exactly. So it checks the switch. Good rule of thumb, bang, sell everything, so you won't cry. It checks the switch for beta flag, skip if set or skip if clear. It checks the pin 0 on port A, and if it's set, it goes to no light. So it will go down to no light. So your program counter literally just jumps onto this address without putting anything on the stack because it doesn't need to go back. It clears the lats and it goes to switch check to start the function over again. Then it goes back down again. If it's clear, it skips the no light. So it basically kind of like jumping straight to here. And it calls this routine and it goes down to here. It puts on the light, copy paste function, set the first tree, returns. When it returns now, it goes to here and it does go back to switch check. That is how it does sanity check your code. So basically when you go through that, it does exactly what you want it to do and you're good. So that is basically how you will write code to light some LEDs. So if you have LEDs in different ports and stuff, you will have to bang sell it in the light LED. So this will be more, it will be longer. That is all, because you have to bang sell each lat. So lat A, lat B, lat C, and light the LEDs that you want to light, and then return. That does be longer, but same idea. Alright, so that's how you will do those things. Subgroup.